What we're going to do today is we're going to find the inverse of a function that we've been given and graph both the original function and its inverse on the same graph. But before we get started on finding the inverse, let's take a look at our original function and see what we can learn about it and get it graphed. Okay, so first of all, let's look for our x-intercepts. Our x-intercepts are when y equals 0. So if we substitute in here, we discover that we've got x-intercept at -1/5. If we substitute in 0 for x, we learn that we have a y-intercept at 1/2. And to find any asymptotes, we need to look at what would our denominator be if it were equal to 0, which is not defined. And we say that 2 minus 5x cannot equal 0, so we have an asymptote at 2/5. Okay, so let's move over to our graph. For the sake of time, I've gone ahead and worked through substituting different x values to find our y values so we can graph here. At -3, we have a point that is slightly less than 1, -14/17. At -2, we have -3/4. We can see it moving upward. At -1, we have -4/7, which is somewhere around 1/2. At 0, we have 1/2, which we determined over here. At 1, we have -2. At 2, we have -11/8, which is a little bit less than -1. And at 3, we jump up to 16/13, which is going to be slightly more than 1. I go back to where is y 0, and that's at -1/5. I'm sorry, yes, -1/5. So, sorry, when y is 0, we've got -1/5. And then 2/5 is undefined. So we have an asymptote there. So we can see our graph goes something like this, approaching 2/5, and it goes something like this there. Okay, so let's move on to finding the inverse of the function. So now we're going to find the inverse of this function. And in order to save time, I've worked through it, and I'll go through it step by step with you. In finding the inverse function, what we basically do is swap out the x's and the y's one for the other. So our equation now becomes x equals 5y plus 1 divided by 2 minus 5y. Then we began to work through the equation so that we can get all the x's on one side and all the y's on the other. So we multiply x times 2 minus 5y, and that equals the 5y plus 1 that was in the numerator. Again, working through, we're going to work out the this side of the equation, multiply the x, so we get 2x minus 5xy equals 5y plus 1. Again, moving terms to like terms, we get 2x minus 1, 2x, bring the 1 over, minus 1. We're going to move the 5x over here, 5xy, we have 5xy plus 5y. Continue simplifying, 2x minus 1 equals 5y times the quantity of x plus 1, and then divide, we get 2x minus 1 over x plus 1 equals 5y. And final solution of the inverse is y equals 2x minus 1 over 5x plus 5. Now, again, I've worked through points. We've got a number of them, but we can see by substituting 0 for x, we find that our y-intercept is 1. Solving for y equals 0, we find our x-intercept is a -1/5. And we find that our denominator, 5x plus 5, can never be 0. We find we have an asymptote at -1. So moving over here to our points. Here's what I worked through. Fairly comparable points for what we did for the original function. We find that, again, -1 is an asymptote. It's undefined. So x equals -1. We find that it goes through 0 negative 1/5. And we find that, we'll start to map some points. So negative 3 we have at a little bit less than 1. I'm sorry, a little bit less than 1, we're up here. Negative 2 we have at 1. Negative 1 is undefined. 0 we have the negative 1/5. At x equals 1 we have our y-intercept. X equals 1 right here. I'm sorry, x equals 1, we have it right here. At 2 it's at 1/5. At 3 it's at 1/4, so we're increasing. Okay, and we've got negative half at negative 4/5, which is almost right there. And then we have negative 3 halves at 8/5, which is approaching 2. So we have a graph, or a line, that goes, is increasing, and over here we have a line this way. So as we can see, our original equation, the multiplicities are odd, means that the lines are going in opposite directions towards the asymptote. And we're done.